Good morning, third grade. Happy Monday. This is Mrs. Swalia here, and I'm going to be teaching you your lesson today to get through 11.8. So we've spent the past 2 weeks learning about area and perimeter, just the very basics, and today we're just going to take it up a notch, okay? So our essential question is, how can you break apart a figure to find the area? So no longer are we going to get regular figures. We want to figure out how we can break them apart to make area a little bit easier, okay? So the first thing that we're going to do is we are going to talk about Anna. Anna's rug has side lengths of 3 feet and 7 feet. What is the area of Anna's rug? The first thing you need to identify is that you only have 2 side lengths. Why? Because a rectangle has 2 pairs of the same side. So we're gonna show this 3 feet by 7 feet rug with our array that we're so used to doing. Remember, 3 by 7? So we're going to get some squares and we're going to organize them into 3 rows of 7. Remember, rows go row, row, row. Columns go up and down. So let's make this a pretty array. Do you see my 3 rows of 7? Awesome job. So today's essential question is, how can we break apart this figure? Well, we can break apart the figure using the distributive property. Do you remember the distributive property? It's when we wrote a line right down the middle like this, and we made the problem a little bit easier. So instead of 3 times 3, we could do 3 times 2, and then we can do 3 times 1. To make it easier, we're using facts that we know. So maybe you don't know 3 times 7, but you know some other facts that you can use by breaking apart the figure. So here is our 3 feet by 7 feet rectangle. So where can we cut this rectangle to make it easier for us? Remember, the distributive property means we're going to split it from the top to the bottom so that one of our numbers is the same. So let's cut it right here. Why did I do that? Because Miss Swalia has now cut 7 into 5 and 2. Do you know your 5s and 2s? I'm very good at my 5s and 2s. So I broke apart my 7 into something I already know. I know how to multiply 3 times 5, and I know how to multiply 3 times 2. So here is my first rectangle. Here is my second rectangle. So what 2 factors do I need to make rectangle 1? If you said 3 and 5, you're correct. 3 long, 5 wide. So what is the area of this rectangle? 3 times 5 is, class, 15. Great job. So that was pretty easy, right? So let's do the same thing for rectangle 2. I know that it's still 3 wide, but now how long is it? It's 2. So I have 3 times 2 right there, right in this rectangle. That's easy, right? 3 times 2 is 6. So what do we do with these two numbers? We have 15 here and 6 here. We should add them together because we are combining the rectangles to get what a 3 times 7 rug would be. So what is 15 plus 6? Well, 15 plus 5 is 20. Add one more. The answer is 21. Now, you didn't have to do the distributive property if you knew that 3 times 7 is 21. But do you see how it's a little bit more helpful to be able to split it using the distributive property into smaller facts? So the area of Anna's rug is 21 square feet. Now, that's what we do if we have a nice, pretty rectangle. The same widths, the same lengths. So what happens when we have a rectangle that looks, or a figure that looks like this? Do you see how I no longer have a very pretty rectangle that I can split and do the distributive property? Right. But what I can do is I can do what's called the additive property of area. Okay, that means that I can split this shape into something that is easy for me to calculate. You can either do this by having a vertical line or a horizontal line. Remember, vertical up and down, horizontal left and right. So do you see how I can split this figure into two different pretty rectangles that I can now break apart? Well, let's start by doing a horizontal line right here. Now, I have two rectangles that I can use. Do you see rectangle 1 and do you see rectangle 2? Now that we've practiced because of the distributive property, now we can figure out what my side lengths are of these rectangles to find the area. So rectangle 1, how many rows are there? 3. How many columns are there? 1, 2, 3, 4, 5, 6. So this is a 3 times 6 rectangle. What is 3 times 6, class? 3 times 6 is 18. Very good. So this part of my figure is 18. Well, let's figure out what this part of my figure is. How many rows are there? 1, 2. How many columns are there? 1, 2, 3. This is a 2 by 3 rectangle, or 2 times 3, which equals 6. Very good. Easy enough, right? So we need to split this figure, okay? And just like the distributive property, I need to know what the area of the whole figure is. So I have 18 here, I have 6 here. What am I doing? What is it called? Combining. Remember, combining is an addition word. So 18 plus 6 is 24 square units. If I went and counted all of these squares, I would get 24 square units. Now that's using a horizontal line. Now this figure, same figure, I used a vertical line. Is that okay? Yes, that's okay. If your mind wants you to break it up this way, good job. If your mind wants you to break it this way, good job. Just know that you need to use them and you need to think about them now separately. Rectangle 1, rectangle 2. So this rectangle, how many rows do I have? 1, 2, 3, 4, 5. And how many columns? 1, 2, 3. It is a 5 by 3 rectangle. So what is 5 times 3, class? Easy peasy, 15. Now we're going to find the area of this. Ignore this stuff. We don't need this anymore because we already found that. So how many rows? 1, 2, 3. How many columns? 1, 2, 3. It is a 3 times 3, which is a rectangle, but it even has a more specific word. That's called a square. All squares are rectangles, but not all rectangles are squares. So what is a 3 by 3 square going to give me? What area? 9. Great job. So if I add 15 and I add 9, because I am now combining the areas for this figure, I would get, again, the answer of 24. Easy enough, right? Let's do one more example. Here we go. What is the total area of this figure? I want you to push yourself into splitting this shape, okay? So they are saying I should split it right here in a vertical line. Do you see how I can do that and make two different figures that I can easily add? I could also do it this way if I would like to, but you don't have to. So let's split it this way, vertically up and down, okay? So I have rectangle 1, rectangle 2, okay? So I have to add. I have to add numbers to make these true. So rectangle 1 is 3 times, what's the right answer? 3 times, if you said 3, you're correct. What is 3 times 3, class? 3, 6, 9. Great job. So remember, I have completed the area of this figure right here. So now I've got to go to rectangle 2, which starts at the dotted line and is all the way here. So they say rectangle 2 is 2 rows of, or 2 times, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 2 times 8, or 2 rows of 8, equals 16. You're right. Let's check our answers. We did it. So do I leave it like this? Do I leave it rectangle 1 and rectangle 2? No, I've got to combine. I want to find the area of the figure, the total area, not pieces. the total. Okay, so if I have 9 here and I have 16 here, then those are the two numbers I'm going to be adding. 9 for this area, 16 for this area. And when you add 9 and 16, remember, 9 is 1 less than 10. If I were adding 10 to this number, it'd be 26. But 1 less means it's 25. So the whole total area is 9 plus 16, which is equal to 25. Do you see how I used breaking apart the figure to find the area of two different rectangles? So remember, you can do this to find area of combined rectangles. You can also use this method as the distributive property of multiplication. Let's make smaller facts to make it easier. All right, that's my lesson for you, kids. That's it. It's time for you now to go on to Go Math and complete your 11.8 area activity. All right, I'll talk to you guys tomorrow. Have a great Monday. Bye.